Hello everyone, I thought I would record exam chapter 2 for you guys so that you can compare what you had on it. So this is f at -1, and so let's see here, we're supposed to use the graph. So here's -1 right here, and so -1, -2, -3. So this is -3. And then f prime at -1 is find the derivative at that point. And you can see that it's a cusp, and so it's undefined or does not exist. I'm going to write does not exist. Okay, and then f at 2, 1, 2, that looks like it's right on the axis, so that's 0. And f prime at 2, well, it looks like the tangent, the slope of the tangent line there is 0. And then it's asking if f at 0 is positive, negative, undefined, or 0. And so it's right here. It looks maybe like it's a little more than 1, but it's positive. And f prime at 0, it's also positive, right? It's going uphill. So the slope is going uphill. Slope is increasing there, it's positive. F at 1.5, so here in this range is 1.5. You can kind of see that even if you weren't precisely accurate, it wasn't asking you for the exact value. It was only asking you if it was positive or negative. So if you're looking at f, it's like -0.8, right? So it's negative. If you're looking at f prime, then you're asking about the slope there, and the slope is positive there. Okay, so that's question number 1. Question number 2 is asking us to prove that this is the derivative using the definition, right? And so we have f prime at x equals, and then the limit as h goes to 0, and we're going to put in, you can put blank if you like that, and we're going to be putting in x plus h right here, right here, right here. So this is 3 times x plus h squared minus x plus h plus 1. And I like to put brackets around this part, like this, and then around this part too. And that helps me not make a distributing error with this negative, which is my common practice. So x, right? So this is going to be 3x squared minus x plus 1. And you see how this negative need to distribute all over h. So I'm going to have to do some quick multiplying of all this out and just be grateful that that wasn't a 3. So 3 times x squared plus 2xh plus h squared. I'm foiling that out, but I have foiled that out so many times that I have it memorized. And I'm going to go ahead and distribute this negative as well while I'm here. So minus 3x squared plus x minus 1. So we're having 3x squared plus 6xh plus 3h squared minus x minus h plus 1 minus 3x squared plus x minus 1 all over h. And this reduces out, right, makes 0. And a lot of things are going to make 0 here. This reduces out, makes 0. And this reduces out, makes 0. So I'm left with things that only have h in it, and I'm going to factor out an h. So h, 6x plus 6x times h plus 3h right here minus 1 all over h. And now the h's cancel, and I can apply the limit. And when I apply the limit, I use substitution only in for h. The x's don't matter. So 6x plus 3 times h, 0, minus 1. So when the dust clears here, I get 6x minus 1 as my derivative, right? And I'm going to put that. And then it's okay to make sure that it's right using my shortcut rules, right? So if I was to take the derivative of this, this is 6x minus 1, and the derivative of 1 is 0. So I think it's a good idea to verify since I have that. So here they've given me this this formula here, and they're asking me. I can see that they're going to ask me to find the derivative of it, and this is a time when I want to work smarter, not harder, and so I want to go ahead and divide this. It'll make it easier for me. So I'm going to divide the pieces. I'm going to write that up here. So 2. I guess I could do it over here, right? Probably should. It says show my supporting work, and maybe I should be writing it over here. So f at x equals 2x to the third over x to the second minus 1 over x to the second plus x to the negative 1 over x to the second. And so this is f at x equals 2x, and here is minus x to the negative 2, and then this is x plus x to the negative 3. Okay, and then now it's asking me to put in, right? It's asking me to put in 0.5 here. And so I had a calculator, and I'm gonna get one. So I'm just filling in 0.5 right in all those spots. It didn't ask me to do more than one, so but I'm gonna just put it in here. Oops, that wasn't a square. And minus, and then parentheses 0.5 raised to the negative 2 plus, and then parentheses 0.5 raised to the negative 3. And I got 5 is what I got. So this is 5. Now it's also asking me to find the derivative and then evaluate that derivative. I'm going to write my work right here at 0.5 as well. So when you take the derivative of 2x, that's just 2. And when you take the derivative, I just have to use the power rule. So that's going to be positive 2x to the negative 3. And this is going to come down here, and this is going to be negative 3x to the negative 4. And I'm going to put in 0.5 in here. So everywhere you see x, I'm going to be putting in 0.5. And again, I'm just going to use my calculator. I don't expect that that'll be a particularly nice number, but I don't even care because I'm not really working it myself. I'm letting my calculator work it. So it is what it is, whatever it is. Oops. So I want minus 3, and I'm going to get 0.5 raised to the negative 4. So I get negative 30, which is actually not an unnice value. I said it might not be nice, and it turns out it's very lovely, actually. Now they're asking me on part C to find the equation of the normal line. And I know the slope of the normal line is normal is perpendicular to the tangent line. So the normal line is perpendicular to the tangent line. So the slope of the normal line is the negative reciprocal if you will. So negative times a negative is a positive, reciprocal is 1 over 30. So the slope of the normal line is 1 over 30. Now I want to find the equation of it. I usually use y minus y1 equals m times x minus x1. And I believe that's what they use in your book too, but I'm fine with anything that you want to use. Our point, our ordered pair that we have, that we're going to be using here, is 0.5, 5. And our slope that we're going to be using here is 1 over 30. And I just felt like I needed to have those right above it, and I don't know why, but that's what I'm going to be using. So this is x minus 0.5 and y minus 5. So this is 1 over 30x, and I have 0.5 times 30, 1 over 30. In my head, I was thinking that it's going to be 1 over 60 as the answer. And then when I got 15, I was like, what did I do wrong? And so this is 1 over 60. and y minus 5. And I'm going to add 5 here. So when the dust clears, I get y equals, and then I'm just letting my calculator do the 1 over 60 plus 5. So 1 divided by 60 plus 5. My calculator said it's 3. My calculator said that's 299 over 60. Sorry. I had a typo on my calculator. Okay. So there's the slope of the normal, or there's the equation of the normal line. Here they're asking me to find the derivative and show supporting work, and I notice that it's a product rule. So I'm going to say my u is x squared, and then my u prime is 2x. And then my v is cosecant of 5x. So when I take the derivative of this, because it's something other than just cosecant of x, I have to use the chain rule in order to take the derivative of it. So my thought, so if it was just cosecant x, I wouldn't have to use the chain rule. So my thought is the outside function, and I'm okay with you calling that f at u if you wanted, is cosecant, right, of u. That's what some people would say. So they would say f at u equals cosecant of u, and I'm okay with that. And my inside function, and then they would call this g of x, is equal to 5x. So that when I take the derivative of the outside, I get negative cosecant cotangent of the same darn inside. So I'm taking the derivative of this, and I'm putting it in my spot here, same darn inside. And then I take the derivative of this, so times 5. And then it's crisscross applesauce. So you can write y prime if you like. Since they wrote y prime, I think I will write the same thing. So I have x squared times the negative of this. And usually you write your negative, so you want to go you want to go common, how you would write it. You write your negative, you write your 5, you write your x squared. So I'm just going to fit it all down there. And then you write your cosecant of 5x, cotangent of 5x, and then you're going to add, because it's product rule, plus 2x cosecant of 5x. And then if you wanted, you could factor it or whatever you wanted from there. But that's fine. That's a good answer. Given this curve here, find dy dx. Show supporting work. So I notice I can't solve for y, but taking the derivative with respect to x of x is just 1. I'm going to have to use the product rule here, and that'll be fine. I'll just use the chain rule there, and the derivative of pi is 0. And so, so I'm going to write this out just so that I can see. I have u equals sine of y, and then u prime, because I have my product rule here, the derivative is cosine of y dy dx. Now I had to really use the chain rule there, right? Because the outside, right? So this was a chain rule. So from here to here was a chain rule. The outside function was sine, right? And the inside, and of course I have an input, it's y. And the inside, and my inside is is what my input was, what my angle was, right? And the derivative, so the derivative of this is cosine of the same darn thing, y, evaluated at the same inside, right? And then the derivative of y, which is dy dx. And then v is cosine of x. V prime is negative sine of x. I didn't have to use any rule from here to here. It's perfect, right? So now I'm going piece by piece, right? So I'm taking the derivative of this, it's 1. I'm taking the derivative of this, and I have set my work up in this product rule. So this is sine, it's negative, going to be negative though, because a positive times a negative is a negative, so I'm going to write a negative here. So it is minus sine of x, sine of y. I'm going to write the x first and then sine of y second. I don't think it matters. And then I'm going to add this plus, and then cosine of x, cosine of y, dy dx, and then plus, and then here I have to use really the chain rule to find the derivative of this, right? So I'll put kind of my work, I'm going to use the chain rule. My thought is the outside is something to the second, and the inside is y. So that when you take the outside, the derivative of the outside, you get the 2 times the something, right? And then when you take the derivative, evaluate at the same inside, y to the 1. And then take the derivative of y dy dx. And then the derivative, so this is my derivative, there. The derivative of pi is 0. Okay, then long story short, I have to solve for dy dx, so I'm going to flip this and this to the other side because they don't have dy dx on them. Your choice on that, and I'm going to factor out a dy dx on these. So dy dx, and your choice on order, cosine of x, cosine of y, plus 2y. And then I'm going to flip this to the other side. So this is going to be minus 1 plus sine of x, sine of y. Then I'm going to divide by that, and then that's my answer. And there's not much I can do to simplify that. A lot of them in your book, you could do some simplifying. And so I feel kind of lucky that I don't see anything, that I can do. You can't write this as tangent. I know we had one in class that had, I think, very similar to this when you took the derivative, and then you could write it as tangent when you got it all divided, but because of the 1 and the 2y, can't do that. It was just a sine over a cosine. So this one here, again, you want to work smarter, not harder, and so the first step is to FOIL this out. So you do not want to start, when they ask you to find the derivative here, you do not want to start using the product rule on anything that you can just multiply out. So 3x to the 4th times 2x is 6x to the 5th, and 3x times this. Now, x to the 4th times x to the negative 4th is x to the 0, which is 1. So this is just 3, so plus 3. And then I'm going to have plus 2x, and then I'm going to have minus x to the negative 4. And so then what I'm going to do is now I can find the first derivative easily by using the power rule. The derivative of 3 is 0, and the derivative of 2x is 2. And then remember, this 4 is going to go down in front, minus 4, and then you're going to take away 1 from the exponent, negative 5. So there's the first derivative. They wanted the third derivative, so the second derivative is going to be 120 x to the 3rd, 4 times 30, drop here. This is going to go away, going to make 0 when I take the derivative, and this is going to be positive 20 x to the negative 6. Remember, you take away 1 from the exponent, a negative 5 take away 1. And then the third derivative, that's the last thing that they asked me to find, and they said don't have any parentheses in your answer. And so the way I've done it, I'm not going to have any parentheses in my answer. So 3 times 120 is 360 x to the 2nd. 6 times 20 is negative 120. Take away 1, x to the negative 7. And then that's a good answer, and if that's what you gave, you got full credit. Another good answer is to put the x to the 7th in the denominator if you wanted, and some people even got a common denominator between the two, and all of those would have been accepted. Okay, find the equation for the tangent line to the curve, y equals this. Okay, so I have to find the derivative, and this is a chain rule. So y equals the square root of 2x minus 1. So I want to find the derivative. So I think about the outside, its chain rule, as being the square root, and the inside as being the 2x minus 1. So when I go to take the derivative, so the derivative of y is y prime, I have memorized that when you have a square root, that that's 1 over 2 times the same square root, so same darn inside, 2x minus 1. You could write this as raised to the half and do the whole thing if you wanted, but it came up so often that I have memorized that. Your choice on that. And then the derivative of 2x minus 1 is 2. So the 2's cancel, boink, boink, And I'm supposed to find the slope when x is 5. So my numerator is 1, and I'm going to have the square root of 2 times 5 minus 1, which is 10 minus 1 is 9. So 1 over the square root of 9, which is 1/3. So the slope of the tangent line is 1/3, and they asked for the equation of it. And I'm used to using this because, I don't know, my beginning algebra book uses this, but I saw that your book uses this as well. So y minus 3 equals the slope 1/3, and then x minus 5. So when the dust clears here, y minus 3 equals 1/3 x minus 5/3. And I'm going to add 3. And I have the plan of using my calculator and not anything else. And so when I use my calculator, I get 4/3. So I just put that in my calculator right now, and I got 4/3. So there's the equation of the tangent line. That's what they asked me for. And then this problem was promised to be on the test, and so here it is. So I'm going to, because when they write it in this notation, I kind of like better to start off with this notation. So I would say let f of x equal cosine of x. And then I want to show that the derivative, which is f prime of x, is equal to negative sine of x. So I know where I'm going. So this would be plugging in here. Oh, I forgot my limit almost. I guess I didn't forget it if I have to only erase a little bit, right? So this is cosine of x plus h minus cosine of x, all divided by h. Then I can use property 3, right? And so to expand the addition formula for cosine. So this is cosine of x, cosine of h. I don't have y, I have h, right? Minus sine of x, sine of h. I almost wrote y. Minus cosine of x. Okay, over h. It's still 0 over 0 if you plug in to find the limit. And so now I want to do a little tiny bit of tricky factoring. I want to put these together and factor out a cosine of x. And if you practiced it, then you kind of have that, oh, that's kind of what I have to do. So I still have my limit. I haven't found the limit yet. And I'm going to factor out a cosine of x from the pieces that I put parentheses around. So I have cosine of h minus 1, and then minus sine of x, sine of h, all over h. And my next thought is that I have a binomial now, this and this, two terms, and I want to split it apart and have them both over h. So I have the limit as h goes to 0 of cosine of x, and then I'm going to write this here as cosine of h minus 1 over h, right? And then minus sine of x times sine of h over h. And then on Khan Academy, he's really careful to say that, well, h is not here, right? But I probably would just apply the limit, is probably what I would do. And so when you have an x, you can't put in 0. And so when you put in 0 here, I know it's 0 over 0, but when we find the limit of that, I know I have h's, but you could, substitute in here x for h everywhere, and I have exactly that, right? The same exact same. So this is going to 0. So this is going to cosine of x times 0. And I'm not writing the limit because I'm applying the limit. And then this piece right here is going to, I know I have h's instead of x's, but that's going, according to this, going to 1. And so this is 0, and then minus sine of x. So there I have proved it, that the derivative is sine of x. Some people put a little box like that when they prove something. I don't know what you want to put. Put whatever makes you happy. Okay. We have 2 more problems, and I have just a few more minutes before I have to go to class, so I hope I can do it. So they're talking about the radius of a circle growing at 4 feet per second. How fast is the area growing when the radius is 10 feet? Just leave pi in your answer. Show supporting work. So I kind of have a circle, and they're talking about the radius, right? And when I kind of read here, if the radius of the circle is growing, so that's dr dt, and they say at 4 feet per second, right? And they asked how fast, so this is what they're asking me to find, and is the area growing, so that's dA dt, and then they say when the radius is 10 feet. So I have to come up with something that goes with a circle that has A in it for area and R in it for radius. So, well, the area of the circle formula, right? A equals pi r squared. So now I've written that down, and so now I want to find the derivative with respect to t. So the derivative of a with respect to t is dA dt, and that's cool. That's what I want to find. And then pi is a constant, so it holds still. And then you take the derivative of r, which is 2r dr dt with respect to t. And then now you can plug in what you know. R is 10 feet and dr dt is 4 feet. So this is pi times 2 times 10 feet. Put parentheses around it if you like. And then 4 feet per second, right? So this is what dA dt is. And that is 2 times 4 times 10 times 4 is 80, right? So this is 80 pi. Feet times feet is feet. Where'd my pi go? Feet per second. Some pi sounds good. I don't know, what kind would I have? If I could have any kind I wanted. Maybe German chocolate pie? That'd be good. Okay, and then one last problem, and it's multiple choice. So it's asking me to find the slope of the tangent line. So I just have to find, I notice here, find the slope, the derivative, right, to find the slope of the tangent line. And I'm going to have to use the product rule and the chain rule. And the derivative of this is 0. So I'm just going to write that down here. Y prime equals 0, right? And then I'm going to have my u, which is 2x, and my v, which is the square root of x squared plus 8. So u prime is easy, that's 2. V prime is chain rule, but I've gotten pretty good. It's the outside, which is 2 over the square root of the same darn thing, x squared plus 8, times 2x. And they told me when x is 1. And so it's okay for me now to plug in x is 1. So I'm going to evaluate this whole thing. I'm going to put my line there and say add x is 1. So this is 2. That's 2. This is 9, so square root of 9, which is 3. This is 9, so this is 3. So this is 1/6. Oh, the 2's can cancel. And so this is 1 over 6. No, the 2's canceled. 1 over 3, 1/3. And so then crisscross applesauce, it was product rule. So plus 2 times 1/3. Plus, right, product rule, 6. So that gives us, whatever that gives us. So 2/3 plus 6, which is 20 over 3. And that's what they were asking. And that's option B. Okay, that's the end of that, and I got to go to class.